The first thing that you need to know here is polynomial division. So I know most of you know synthetic division, but synthetic division would not do. You'll need to abreast yourselves with polynomial division. So let's say x squared minus 5x plus 6. How do I divide this by x minus 1? So I know very simple. We take this x over here and multiply this x by x. That makes it x squared minus x. I'm going to change signs here, pull down the plus 6, and then multiply this by x minus 4. Sorry. So that makes me minus 4x plus 4, and my remainder here is 2. So I can then say, I can write down x squared minus 5x plus 6 as x minus 4 plus 2 upon x minus 1, right? Also, if I call this function as f of x, the remainder here is 2. If this function is called as f of x, let me try and find out f of 1. F of 1 here is going to be 1 minus 5 plus 6. That gives me 2. Bingo, that's the same as the remainder which I calculated by polynomial division. So this is something that we call as the remainder theorem. Extremely important from the SAT point of view. My remainder theorem says that if a function f of x were to be divided by x minus a, I can simply calculate my remainder by calculating f of a. Extremely useful. You'll get multiple questions on the remainder theorem. What next? What next? The next is a factor theorem, which is nothing but a natural extension of the remainder theorem. So supposing I say I have a function here called f of x equals x squared minus 5x plus 6. And I wanted to divide this function by x minus 2. Remember, when it is x minus 2 is the divisor, you calculate f of 2. If x plus 2 were the divisor, you're going to calculate f of minus 2. Right, so what do? I just calculate f of 2. And I get that as 4 minus 10 plus 6, and this vanishes, right? Now, if the remainder is 0, what does that mean? It means that x minus 2 is a factor. That gives me the factor theorem, extremely useful here. Let's write it down. Let's see what does it look like. I can state the factor theorem two ways. The first one is if x minus a is a factor of f of x, then I can conclude that f of a is going to be 0. Let's take a question on this. Suppose I say x minus 1 is a factor of x squared minus kx plus 1. Then what would be the value of k? So simply, since x minus 1 is a factor, I would calculate f of 1 as 1 minus k plus 1 and equate this to 0. That gives me the value of k as 2. So this is one kind of questions that you'll normally get here. Moving on, there's one more way in which I can state my factor theorem, and that is if f of a is equal to 0, this implies that x minus a is a factor of f of x, right? Let's take an example. Suppose I have a parabola here. This is -2 and this is 3. From the graph, what is f of minus 2? Obviously it is 0, because that's where it is intersecting with the x-axis. So when x is -2, the y value is 0 here. If f of minus 2 is 0, then I can conclude what? X plus 2 would be a factor of my function. Similarly, I know f of 3 is 0, and that would mean what? That would mean that x minus 3 is also a factor. So I could then write down the equation of this function as x plus 2 times x minus 3, Of course, I could have a constant a here that does not impact my roots, which is about the steepness of the parabola. So this is another way, I can put the factor theorem to use. But guys, both remainder theorem and factor theorem are extremely important propositions. You'll find multiple questions here on these. Okay, moving on. Next, let me come down to parabola. And this is often, this is a topic that kids normally struggle a lot with. So I'm going to spend some time here. I had the option of, covering up all 5 topics superficially. I chose to cover 2 of them in great detail. So quadratics is what we study. So let me start off with what is it that I expect all of you to know. Suppose I have an equation or I have an expression, right? Such an expression is called as a quadratic expression. If I equate this to 0, it becomes a quadratic equation. And this is going to have 2 factors, 2 roots as such, x1 and x2, which you can find out either by factorization or by splitting the middle term or by using the quadratic formula, which I'm sure all of you know pretty well. You've learned them in grade 9 or 10. Right? Okay. Now, we know that this argument under the radical is called as the discriminant. And the nature of my roots would depend upon this particular discriminant. If d were to be greater than 0, I know my equation is going to have 2 real roots, 2 real and distinct roots. If d is equal to 0, I know I'm going to have a double root. And if d were to be less than 0, I would have imaginary or complex roots, as in no real roots. Correct. Apart from this, there are 2 important things that I want you to know here and remember always. The first is irrational and complex roots shall always occur in conjugate pairs. What does that mean? If one of my roots is 2 plus root 3, then the other root is going to be conjugate of this, which is 2 minus root 3. If one root is 4 minus 3 iota, then the other is going to be 4 plus 3 iota. I'm sure all of us know conjugates. There's one more thing that I want you to know here. If alpha and beta or x1 and x2 are the roots of this equation, then the sum of these roots is going to be negative b upon a. This is an extremely important property. There will hardly be an SAT on which you'll not have a question on one of these 2 results. Though this question may not be what I'm doing, may not be directly framed. Right? So the sum of roots is negative b upon a, the product of roots is c upon a. Right, I'm going to put this to use on a specific question. I'll just take a moment of your time. Just give me one moment, guys. So I'm just going to show you a question from one of the actual SATs over the past 3 years. And then I'll discuss about the applicability of the result that we just learned and how is it that we all make a mistake in normally attacking this question. Can I find it? Yeah. Okay, there I got it. Look at this question. Okay, x times x plus 2 equals 8. The normal response for a student to solve this question is that they're going to open the brackets, transpose the 8 to the left hand side, and now use the quadratic formula to get both the roots, right? I would have something smarter to offer here. I know the sum of roots of my quadratic equation is given as negative b upon a. So in this case, this becomes negative 2 upon 1. So I know the sum of my roots is going to be negative 2. Option 1 gone, option 2 gone, last option gone. C is the answer. Does that make sense for you? It can be a brilliant time saver, right? Time saver, effort saver, everything. Okay, let's get back to the class. Oh, here we go. So, now we come round to our session. This is my quadratic expression and I put it equal to 0, making it an equation. I know when I graph this, this is going to be a parabola. Also, this parabola could look like this or it could look like this. Whether it's a parabola opening upwards or parabola opening downwards shall depend upon the value of this a. When a is greater than 0, this would be the case, and with the negative a, the other one is going to be the case, right? Now, I want you to know 3 important things about the parabola. The first one, remember the first session we talked about calculating y-intercepts and what we discussed. How do we define the y-intercept of any function? That's the y value when x is plugged in as 0. So if I plug in x as 0, I'm going to have the y value as c. So my first thing is c gives me the y-intercept, which on the graph is this length, right? Second, I know this has 2 roots, x1 and x2. These are the x values for y is 0. So let's say this is x1 and this is x2. So my second observation says x1 and x2, that is the roots are the x-intercepts. The third one is rather important. If I take a look at this parabola, this point is called as the vertex or the turnaround point, right? And if I exclude this vertex, then for every y value here, we can have 2 possible x values. For every y value, vertex is the only point where corresponding to one y value, there is just one x value and not 2. So those 3 important observations I make about the parabola before we go back and study those parabolas. So we're now going to do a large number of parabola drawing, right? Case 1, if a is greater than 0 and d is greater than 0, what would my parabola look like? I know a greater than 0 means it will be a parabola opening upwards. And d greater than 0 means I've got 2 real roots. That means my graph is going to intersect with the x-axis at 2 distinct points, this one and this one, correct? Second case, a is greater than 0 and d is equal to 0. We know d equal to 0 means what? D equal to 0 means a repeated root. Repeated root, double root, which means it will practically have just one root. So let's say I keep on moving this parabola upwards. Till now it has 2 roots, 2 roots, 2 roots, 2 roots, 2 roots, 2 roots, now no roots. What is the only way in which I can have a single root? That would be when the vertex lies on the x-axis. I'll draw another one, right? So wherever my discriminant is 0 or I have a repeated root, the only way that repeated root is possible is when the vertex lies on the x-axis. And the third case, a greater than 0 and a negative d. Negative d means imaginary roots, which means my parabola should not be intersecting with the x-axis. The entire parabola now would lie above the x-axis. Fair? You'll normally get questions here, you know, where based on a graphical parabola, you're required to take out a lot of information. So you should know this from scratch. Second, how would these two cases look like if A was, less than 0? Three cases. This is when D is greater than 0. This is when D is equal to 0. And that's the case when D is less than. Okay, moving on. Let's go back to the parabola. My parabola could look like this, or it could look like this. So when A is greater than 0, my parabola would not have a maximum here. The open ends of the parabola can be extended upward. So as the value of x keeps on decreasing or increasing on both sides, the y value will keep on increasing right until infinity. But for all x values, the y value can never go below this. So we say we have a minimum here. Similarly, if A is negative, this would not have a minimum, but this would have a maximum, meaning thereby a quadratic function has only one extrema, either a minimum, or a maximum. And whether it has a minimum or it has a maximum would depend upon what? Would depend upon the value of A. With a positive A, it will have a minimum. With a negative A, it will have a maximum, right? And how do we find out where would this maximum exist? So the x coordinate of this maximum or minimum would both be given by the same formula, which is negative b upon 2a. So when x is equal to negative b upon 2a, your y value or the value of the function shall become minimum or maximum. And the corresponding y value can be figured out by plugging in the value of x as negative b upon 2a. Simple. And then this would give me the vertex of the the coordinates of the vertex. Fair? You need to remember this one pretty well. Let me give you an example. Suppose the depth of a deep sea diver below the ocean surface is modeled by this equation. Would this have a minimum or a maximum? This would have a maximum because my coefficient of x squared is negative. For what value of x would the depth become maximum? Simple. You use x equals negative b upon 2 times of a. So that gives you 1. So I know after 1 minute, the diver would have the maximum depth. And how much would that maximum depth be? You just plug in x equal to 1 here. So minus 1 plus 2 plus 19. That gives me 20. So I know if I draw this graph, this is going to be an inverted parabola and the coordinates of my vertex are going to be 1, 20. Fair? Okay. Moving on. So I want all of you to now find out whether this would have a minimum or a maximum. It would have a minimum. Where would it exist? X equal to 1. What would be the minimum value? Y equals 4. So I know in this case, the vertex is going to be 1, 4, right? Now, one very important technique that you need to know on this test is how to complete squares. So for those of you who do not know, let me tell you, if I had to complete squares for x squared plus bx, please know here the coefficient of x squared is unity. It is x squared plus bx, not ax squared plus bx. Then if I had reduced my expression to this format, I can very easily complete squares by adding and subtracting square of half of b, right? So let's say what is my b? B here is negative 2, half of that is negative 1 and square of that is 1. So I add and subtract 1 to it. Correct? Now this part, this becomes x minus 1 the whole square plus 4. Now look at this one very carefully. Y is a sum of 2 expressions, of which 4 is a constant. So y would become maximum or minimum According as per x minus 1 the whole square becomes maximum or minimum. But x minus 1 the whole square cannot have a maximum value. As x keeps on increasing or x keeps on decreasing, this value will keep on going up. But I know this being a perfect square, its value can never be less than 0. So it will have a minimum. And minimum would be where? When this vanishes, that means when x equal to 1. And when x is 1, y would be equal to 4. So my vertex coordinates are going to be 1, 4, which is what we calculated earlier. But there's a difference. From this form of the quadratic expression that we call as the general form, you have to calculate the vertex. But from this form of the quadratic expression, which is what we call as the vertex form, I can see what the coordinates of the vertex are. I do not have to calculate. So we say the vertex values, they exist as constants or coefficients inside this particular expression, right? So let's move on further and discuss the vertex form, which is all too important over here. This is my vertex form, and when expressed in this format, the vertex is given as h comma k, right? You'll normally get a question that says, which of the following equivalent forms expresses the minimum or the maximum or the vertex as constants or coefficients? What do I mean by this? Students often get confused with this one. So when I say vertex is expressed as constants or coefficients, it means the vertex value actually exists as numbers in that particular expression. So by just taking a look at this expression, I can tell you that my vertex is h comma k. So the vertex form expresses the vertex as constants or coefficients. One more, let's see. Minimum or maximum, it will have a maximum because a is negative. And what will be the coordinates of the vertex? A lot of you would be inclined to say 2, 5, which is incorrect. The correct answer here is minus 2, 5, because you'll have to put this into a form which exactly follows this one. And I want to write this in this form. I'm going to write this like correct. And now it is exactly identical to the upper one. And comparing this to this, the h value is negative 2 and the y value is 5. There's a third form of the quadratic expression. We call this form as the factored form. And what can I read from this? From this, I can figure out that my roots are alpha and beta. So the factored form expresses the roots, or sorry, what I'm doing, x-intercepts, smudging, excuse me guys, as constants or coefficients. Right, now how do we find out the vertex of the factored form? Well, you might say, I'm going to multiply a inside and open up the brackets and then use x equals negative b upon 2a. That's going to be cumbersome, guys. Let's look at it this way. This is alpha, this is beta. And remember, we discussed 2 points having equal y values. They'll be equidistant from the vertex on both sides, right? So which means if x is the x coordinate of the vertex, then beta minus x would be equal to x minus alpha. And that gives me x equals alpha plus beta upon 2. And the corresponding y value can be found out by plugging in alpha plus beta upon 2 into your function. Okay. Okay, one last concept we need to study. Let's take up a question before that. Minimum or maximum? Maximum, because your A is negative. And what are the coordinates of the vertex? So I know my roots here are -2 and -4. So the x coordinate of the vertex would be given as half the sum of these two roots. So this is going to be -3. And to find out the y coordinate, what do? You just plug it this and this over here. So you'll get y equals -3 into -1 into 1. That gives me 3. So my vertex is -3, 3. One last concept that you need to learn out here is axis of symmetry. So axis of symmetry is nothing. It's a straight line that passes through the vertex, right? And my parabola is symmetric around this axis of symmetry. So 2 points which have equal y value would be equidistant. So this is xy from the axis of symmetry on both sides. So if this point is x plus t comma y, then this point is going to be x minus t comma y. I'll give you an example. Okay. Here I have a parabola. The vertex is 3, -5. One point on this parabola is 7, 41. Another point on this parabola is a, 41, where a is not equal to 7. What would be the value of a? The two ways to solve this question. One, I may write down the equation of the parabola using the vertex form. So let's say some a is already constant here. Let's not use a. Let's say this is going to be some constant b into x minus 3 the whole square minus 5. And now I plug in this point into this equation for xy and find out the value of b. And then equate that to 0 or equate that to 41, I'm so sorry, and find out both the x values. So one of the values would be 7, the other one would be your answer. This is a much better way to do it. I know 2 points having equal y value are going to be equidistant from the axis of symmetry, which in this case is x equals 3. This distance is 4. This point lies 4 units to the right. So the other one would lie 4 to the left. And from 3, if we go 4 to the left, I'm going to get -1. So I get the value of a is -1. Is that pretty simple, guys? So I think that's what I had to tell you for today. I could go on and on and on, time permitting, but I'm not really permitted that kind of time. Would be more than glad to take up your questions now.
It was really a good session, so got to learn many small detailed things. First of all, I could just notice that many of the things we know, but students fail to use it and implement it and save time. So that was really one thing to draw. I would like to take you through through the questions. So, so when will we get the email regarding the exam if we have already
You
registered?
should get it 2 days before the scholarship test.
Okay.
The results would be posted on the Next Genius website by 10th of February.
Okay. What if I registered for the scholarship test only of SAT and want to also take ACT, but not?
You can register now, that's okay.
Okay. Okay. Where is the registration for the scholarship test? You must have received email.
Yeah, you must have received email. Additionally, you can go to the Next Genius website, webinar website. You'll find the link over there.
As well as if in case you're on a laptop, you would be redirected to the scholarship form after this session ends. So are we going to conduct calculus?
I don't think so. Not as of now. Maybe we'll plan something later. As of now, it's not on cards.
Okay. Which book is best for SAT math? You can refer
You use College Panda. Is a good book.
College Panda.
Even Barron's, I listed them all in the first session. Barron's, book. Math workbook for the new SAT is pretty good.
Okay. So how to become perfect and clear in mathematics? I'm feeling confused.
Work on your concepts and practice a lot. One more question. Geometry questions are there in SAT, but hardly two of them. So I'm not.
Okay.
Eligibility for scholarship test. You should be currently in grade 10 or grade 11.
What is the fees for scholarship? No fees.
Fees for scholarship test is nothing. It's free of cost. Subject test cancellation. So the subject tests were serving a repetitive purpose. Please understand, subject tests are required by the universities to additionally examine the academic competence of a student. So there are two options here. One was the APs, one was the subject SATs. The College Board has taken a clear decision in favor of the APs. They say we don't want to go ahead with both of these tools. We'll just go with one. Keep a watch out for this space. We'll be coming out with something for the APs, I think, next month.
Okay. Sir, is NTSE and SAT similar?
No, it's very different. There's no connection here.
Okay. So when is a good time to take SAT?
As early as possible, once you come to grade 11.
Should I take APs?
You have to consult your admission counselor. I cannot comment on that. I will always recommend they're good. Depends upon what other things do you have with you to do.
So one question, I don't know how we would answer. I don't have surname. Is it necessary for my future?
It's a very technical question. I don't think it is. You have the right to exist even with a single name. So surnames are not mandatory here. So you should take the essay in March if it is happening. That's okay.
Most common topics in SAT math?
It's basically algebra-based test. So
can I take SAT test in class 12?
Yes, you can.
So how can I prepare if in case the individual has no counselor?
I mean, you can probably do a bit of a Googling, find out the information. It's not that difficult, and there's so many resources available.
Okay. Okay, I guess that's where the questions by far. And so can we score 800 in maths within 30 days?
Oh, yes, you can. You go after it. Yes, you can do that. Math on the SAT is not very difficult, honestly.
How much in-depth is complex numbers tested?
Not much, not much. There are only two types of questions you normally get on complex numbers. One is like rationalization, and the other is exponents of complex numbers.
So the surname person in student is asking is in SAT form that is mandatory. So how can he?
Yeah.
The student who asks if the surname is compulsory or not, he's
no, you can use, just go to the College Board website and Google how do I fill up the form. You'll find some links.
Okay. Okay. So someone is, what if I won't be able to get next year's scholarship? What would be the fee of the course?
They can go to my website, saturnpaper.com, and check it out.
Okay. Okay, so I would take a last question for this session. So how to save time on SAT math?
Attend our session next week that will talk about the test taking strategies.
There were really very well answered all the questions. So thank you for that. And
thank you, Harshal.
Talking about the last question, I would really highly recommend to attend the sessions. There are many small detailed tips you would be getting, which will help you a lot in saving your time and getting to know how can you go ahead in the journey of preparation. So thank you everyone once again. See you in the next session. Thank you so much.
Thank you so much. Thank you. Bye-bye.